Welcome to the part 2 of Pandas video series. In the previous video, we looked at series, and in this one, we are going to look at data frame. So let's get started. We are going to create data frames from the list first. So let's create a list, and this list will contain, let's say, width and height. So because data frames are rows and columns, we will need few rows and columns. So let's say 10, 20. So we have a two-dimensional list here. So let's create a data frame here. So we are going to create data frame, and if I press a Shift tab, you will see that the first argument is data. So let's pass on the data, which is data underscore LWH, and there we have it. So this is our data frame, and it looks very similar to a spreadsheet where we have rows and columns. We did not supply the arguments about a row and columns, like what should be the row number or row name or column name. So by default, it has been 0, 1, 2 here in the row numbers and 0 and 1 for the column numbers. And both of these values are customizable. If you remember, the row numbers are set using index. So it will be pd.dataframe and a data, and let's pass on index. And this should be a list which contains exactly 3 members. So A, and let's execute this. And now we have a data frame where we have the row numbers or index. Now let's copy this entire thing. I'm going to press a Shift tab 2 times so that we can see the expanded version of this signature. So we have data, same like series. We have index, same like series. But now we also have 1 columns. So what we can do now is we can provide one more argument, and this is going to be columns. We have 2 columns, so we have to supply a collection with 2 members. So let's call it width and let's call it height. So now we have proper row number and column number. So this was our first data frame. Now, as of now, it looks very similar to a spreadsheet and it has a lot of interesting features, but we'll come to that in a while. Just now we looked at series and how series can be created using NumPy arrays. So similarly, we can also create data frame directly from NumPy arrays. So I'm going to take a shortcut here. I'm going to copy everything and convert this into NP array. So now we are passing NumPy array, indexes and column as before, and we have exactly the same results. Now let's talk about using dictionaries. Now this is where I want you to pay attention. Now if you remember, we created this dictionary and we used it to create a series. So let me do that again. So let's create pd.series, and if I pass data dh, this a series was created. Now if I just change series to data frame, what will happen? We will have errors. And what is the error? If using all scalar values, you must pass an index. So what is a scalar value? A single number. So if you are passing single digit, like what we are doing here, we are passing 4, 5, 7. So what we need to do is we need to pass index as well. So index is going to be, let's say, 1, 2, 3. Now this is something we were not really expecting. So we provided 3 indexes and it created 3 rows. Instead, what we have is 3 columns of data. So this is something I want you to remember, that this is where creating data frames versus series is entirely different. So we can fix this problem here by providing index as just one single number. So if we provide index equal to 1 in square brackets, we will have only one row of data. But this is again all hypothetical. So let's go ahead and do something practical. So let's create a dictionary, and this dictionary name is, let's say, flower. And what it contained is, let's say, petal length. So I'm going to fast forward this video. So I just created this dictionary with 4 attributes. So if you look at this is just an observation for a flower, and we have petal length, petal width, sepal length and sepal width. So these are the 4 values that we observed. So this was for one flower. Now what if there are multiple observations for a lot of flowers? So in that case, probably we will have a dictionary called flowers, and we will not have one values but multiple values in a list. So let's say 5. So it will be something like this. So as we can see here, there are 4 values. So this is a list with 4 values. So all these should be also with length of 4. So let me quickly fill this up. So now we have a dictionary which contains 4 attributes or 4 keys, and every key is containing a list with 3 members. So let's create one data frame. So pd.dataframe, and let's use this flowers. So the real world data is going to look a lot like what you have created in a dictionary. So remember this example, this is going to be of lot of use because we will be working with practical data sets which look like this. Now if we store this data frame in a variable, let's call it a df, so we can directly print a data frame, or we can access the values. So if we access the values, what we have here is numpy array which contains only the values, which does not contain the columns or headers, and it does not contain the row number or indexes. Similarly, we can also check the shape or the dimension by simply calling a df.shape. And because it looks like numpy array and it is actually built on the top of numpy array, lot of numpy arrays function will work as it is. For example, if you want to check the maximum values, there we have it. For each column, we have the maximum values printed out. If you want to check the mean, we have the mean. If you want to check the min, we have the min. So as you understand now that list became very powerful when we created numpy arrays, and numpy arrays have become very powerful when they have been transformed into data frames. What you have seen so far is just a glimpse of how powerful data frames are. In the upcoming videos, we are going to look at importing more data, more real life data, and we will see how data frames can help us manipulate data very easily. So I'll see you in the next one.